All right, Yuri says, welcome back. We're going to have a quick video going over there's 4 types of weather fronts. 3 of them are the main ones, and then we'll touch on one last one. Yuri, stop petting me, would you? The types of fronts there. So, Yuri's first drawing here, very nice one, shows a basic low pressure system. So you got to remember that low pressure is the lousy weather, and the fronts generally extend off of that. So it circulates around the lows. The symbols for the fronts point in the direction that the front is moving. So all of these fronts are moving that way, which makes sense because the air circulates around that low pressure. Okay. Fronts on normal weather maps are color coded. On like a test, they wouldn't be color coded, but they still have those symbols. So you have the rounded off symbol that symbolizes warm air, and you have the pointed symbol that symbolizes cold air, and if you combine the two, that's where the cold and the warm have kind of caught up to each other. So we'll go over those 3. What you need to do is, this is the map view. When you look at fronts from the side view, you've got to be able to mentally picture the air coming off of the ground. This is like the surface of the earth. So I am going to cut this just like we're taking a slice of the earth, and Yuri did an amazing job. Let's see if we can show these. So here's your weather map, and if we tip it to the side, you can see this is the side view. This is the cross-section view of those fronts. So you can see, now you can't see. This is the side view of those fronts. So if I put that weather map view down, you can see the cold air, okay? And the warm air, everything is moving this way. See that arrow magically appear there? The cold air is moving this way. The warm air is also moving this way, and then you've got some cool air. And these fronts keep repeating themselves, but the basics of it is cold air is much more dense, it's a better pusher. It hugs the ground and it pushes everything out of the way. So it pushes that warm air out of the way pretty quickly, and it forces it all up. Warm air wants to rise on its own because it's less dense. So as it rises up quickly, what are the clouds going to look like there? Boom! It's a really intense storm. Thunderstorms are when cold fronts come through. When you get a big difference between cold and warm air, a lot of warm air is rising up really tall, really fast. You get intense storms coming back down there. So they're quicker storms, they're shorter duration, higher intensity. So the storm happens right on that front for the most part. So cold front on the front, intense, often thunderstorms. This can also create tornadoes in really drastic differences between cold air and warm air. And then the warm air is also moving this way. And so you can see that warm air, it's not a good pusher. It wants to rise. So when it hits that cooler air, it just kind of ramps up. Okay, so what kind of clouds are going to form there? Much thinner clouds, but they're longer clouds. Okay, it's a longer duration, but they're thinner, so it's a less intense storm. So as this warm front is pushing through here, here's where the warm front is. All of the weather's ahead of the warm front. Okay, and the clouds start out really high, and as that warm front gets closer and closer and closer and closer, the clouds get lower in the sky, and you have a longer duration. You might have 2 or 3 or 4 days of dreary kind of rain. For warm fronts, all of the weather's ahead of the front, and it's not as intense, but it's a longer duration. You might have 2, 3, 4 days of rain. And for the cold front, the weather's on the front, and it's a much more intense storm. So that's the difference between those two. And if those two, eventually the cold fronts like to catch up to the warm fronts because they're better pushers. They move quicker because they're a better pusher. That's when you get what's called an occluded front. And that's just basically, if you took these two and you combined them together, you get a really intense storm system. Basically the characteristics of both combined. Okay, you need to be able to make some predictions for some of these and some descriptions of what the weather is currently like. So currently the weather at Y would be warm with approaching clouds. Okay, it would be warm since the cold air is coming towards Y, the pressure is going to be rising. Okay, cold air, higher pressure. The pressure for Z, as the warm air is approaching, your pressure is getting lower and you get lousy weather. So this is really where the lousy weather part can come into play. The temperature forecast, it's going to get warmer at Z, okay, and it's going to stop raining. For Y, it's going to get cooler and it's going to start raining. And for Z, it's nice and clear and it's probably going to stay that way for the forecast. So hopefully those make sense. We'll do a few questions on those. And oh, one last front, I completely forgot. When the air masses are moving in opposite directions, that'll happen occasionally. They kind of collide and stall out. That's called a stationary front. It rarely shows up. It's just the opposite. Instead of both going the same direction, it's opposite directions. Thanks for whispering that in my ear, Yuri. Okay, so here's a question that shows the weather map view. So this is like a top view. The passage of a cold front most recently influenced the weather of which two cities? So let's look at this kind of weather map real quick here. This is a warm front, okay? So all of this air right here is going to be warm air, okay? My best drawing skills here. And this is the front of the warm air. This is the cold front. So here's the front of the cold air, okay? And it kind of helps to picture this, okay? So you can't do this on the test, but what cold front most recently influenced the weather of which two cities? The cold front is moving this way, so those arrows or the symbols point the direction that it's moving. Fargo, Minneapolis, Kansas City, Oklahoma City, Kansas City, and Minneapolis would be my choice, okay? If the question was the cold front will influence the weather of which cities, it would be Chicago and Memphis would be next, and then Detroit, Cincinnati, and Atlanta would be getting a cold front. Okay, so currently versus forecasting, just pay attention to how it's worded in the question there. Here's the side view. Okay, which type of weather front is shown? You've got cool air. Here's the arrow. This is the front of that cool air right there. It's an intense storm. You've got really tall clouds. That's a cold front. So cold fronts have that general pattern. Ground level is moving towards city B. What type of weather front? So this right here is warm air. We're going to do a video on air masses next. That's tomorrow's video. So these will make a little bit more sense at that point. Okay, so if the air is moving this way and you're getting those clouds that are kind of ramping up like that, this is warm air ramping up. That's a warm front, okay? And you get those extended periods of rain. Here's a diagram and it tells you it's a cold front, okay? It's an intense storm right on the frontal surface. And what's happening to the air? Why is there clouds forming here? Remember, wherever the clouds are getting forced up, you're going to get rain. That's when you get the clouds, whenever you get rising air. So rising air, A or C is my choices. Which kind of air is rising? It's the warm air that's rising. Yes, it's a cold front, but the warm air is doing the pushing, or the cold front's doing the pushing, and it's pushing up the warm air. So you've got rising warm air. Rising warm moist air makes the most sense to make clouds. And here's a real nice diagram that puts all of these together, okay? So you can see you get your clouds here. Wow, nice drawings. And you get your clouds here. Wherever the air is rising, rising air makes rain, rising air is clouds, okay? If the two catch up to each other, what's that called? That's the occluded front. Right, so those are all your fronts, and we'll go over what the air masses are in the next video. Hopefully that makes sense. Ask questions in the comments if you have them. Must have been a cold front, lightning, thunderstorms.